In my previous video, I explained how torque is equal to a radius multiplied by an applied force. In this video, I wanted to discuss a concept known as moment of inertia. To do this, I'll need to combine a few concepts from some of my previous videos, so be sure to watch those if you haven't already. I'll link these specific videos below in the description. Newton's second law tells us that force is equal to mass times acceleration. In my video on rotational motion, I showed how you can convert between linear and rotational quantities. If this acceleration represents the tangential acceleration of a rotating object, we should be able to write it as an angular acceleration. To do this, we can say that force is equal to the mass of a rotating object multiplied by the radius of revolution multiplied by the angular acceleration. If we multiply both sides by the radius, we can see that the left side becomes torque. We can then see that the equation becomes torque is equal to mass multiplied by the radius squared multiplied by the angular acceleration. This equation can be thought of as the rotational equivalent of Newton's second law. In that case, torque is equivalent to force, angular acceleration is equivalent to the tangential acceleration, and mr squared is equivalent to the mass. This quantity is known as the moment of inertia of the object and is abbreviated with the letter I. However, this is only the moment of inertia for a single rotating particle. For solid objects, we need to sum together the moments of inertia for every particle. This means that we must sum the mass multiplied by the distance from the center of rotation squared for each particle. For a solid object, we can also say that the sum of all torques is equal to the moment of inertia multiplied by the angular acceleration. This is because the angular acceleration will be the same for every particle in that object. In most cases, you won't really be asked to calculate an object's moment of inertia. In most cases, it's just a quantity that you'll need to solve a problem. You'll usually be able to look through a table that lists the moment of inertia for various objects. For example, the moment of inertia for a sphere is equal to 2/5 multiplied by the mass times the radius squared. It's important to note that these tables are only relevant for uniform solids. So what exactly is an object's moment of inertia? In the same way that an object's inertia is its tendency to resist changes in linear motion, an object's moment of inertia is its tendency to resist changes in rotational motion. An object with its mass concentrated further away from its center of rotation will rotate more easily, and therefore has a larger moment of inertia. Moment of inertia might seem like an abstract concept at first, but if you compare it to its linear equivalent, it becomes easier to understand. I hope that this video demonstrates that, but if you still have questions on anything, feel free to comment below and I'll do my best to answer them. Thanks for watching.